Hello, I'm Sam Markell, extension plant pathologist at NDSU, and thank you for joining us at the Devil's Lake Roundup. I'm going to be talking about diseases as part of the driving production research session. We'll talk about things to watch for in 2022. So I've got 4 diseases I'm going to highlight. Rust and soybean cyst tend to show up more and cause more problems when it's dry. White mold and root rots tend to cause more problems when it's wet, although of course there's exceptions to every rule. So let's start with rust. So rust is very specific to each crop that it occurs on. So rust to dry beans doesn't go to sunflowers, and rust on wheat doesn't go to dry beans, for example. But I'm showing you a picture of a sunflower leaf to start. And the reason is that it illustrates a point about rust needing free moisture. It needs dew, it doesn't need rain. So I was walking through a sunflower field and I saw this leaf. It was horizontal to the ground, so it was flat to the sky. It had a little depression in the leaf right here in the middle of the screen. And where you had that depression, you had a lot more dew. And when you had more dew, you had more rust. In fact, it really created a little bit of an epidemic right in that depression. And that is consistent for rusts across any crop. They're all different pathogens, they're specific to the crop they go on, but they all need that free moisture. So something to keep in mind is rust doesn't need rain, it needs dew or fog, something free moisture on the leaf. It's really important for rust to get going. When you see rust on dry beans, you don't see it generally all across the field right away all at once. What you usually see is a hot spot or several hot spots. So little areas in the field that have rust usually starts in the middle of the canopy, appears to work its way up, and then it'll go across the whole field. So I'm about 15 feet away or so, 10 feet away from a hot spot. I'm going to walk a little bit closer to it. And you can kind of see there's rust on there, but you really have to get into the middle of the canopy. Take the leaves, flip them around, look at them, and there's a lot of rust in that hot spot. So that's when you usually first see rust. And then once you get the hot spot, it can easily spread to the rest of the field. So if you see a hot spot, especially after, say, in July, you might want to think about managing it. Okay, this is what rust will do if it gets out of control. So this was, I believe, 2018. I was near the Devil's Lake area. This is a field that got hit with rust. Got hit with it fairly late, but still caused some yield loss. You can see there's tons of leaves on the ground. The leaves that are remaining are covered with pustules. You can see them on the left. And the pods, the shriveled pods, are also covered with rust pustules. So managing this, the first thing is crop rotation. Crop rotation is really important for every disease we talk about. It's better and worse than for some or others. It's more of an effect on some things, but rotation is something that we really need to emphasize. Genetic resistance is really good when it works. And we've had great genetic resistance. It was very effective against the pathogen for quite some time. About a decade ago, the pathogen started to overcome the genetic resistance in our beans, and so now a lot of them would be considered susceptible to rust. And then fungicides, they're very important too. Timing is really important with this, and you don't have to do it prophylactically like white mold. You can scout and wait till you find it. If you don't see it, you don't need to spray. Typically, you'll see rust show up sometime in July after a wetness event. Big rain, couple nights that follow the really heavy dews. You might see rust show up about a week after that. And there's multiple chemistries that are effective. And without going into too much detail, I just want to emphasize that there are a lot of products out there. So this is a trial we had in 2020 where we had some rust. We didn't have a ton of severity. You can see the scale here goes from 0 to 10%, but it's enough pressure to separate out some of the chemicals. So how you read this is the bigger the bar, more disease. So the yellow is the non-treated control. It's the biggest bar, it had the most disease. All of these products helped to some degree or another. We had not statistical separation in yield, but you can see numerically every product sprayed there was a higher yield than the non-treated control. 2018 we had another trial, and this was a little larger. There's some other products in there, there's some generics as well. So the non-treated control is about 7%. Some of the products that we tend to think of as white mold products are not as effective on rust as some of the others, but you can see pretty good separation with the different products that we're applying. So there's lots of chemistries out there, and it tends to be that triazoles and strobilurins are a little bit more effective than say an Endura or a Topsin. Again, we didn't have enough pressure here to separate yield either. but the chemical separation is pretty good. Switching gears here to white mold. So white mold is a problem that can show up even after you have a drought, even after you have a long drought. And the reason is these black structures that I'm holding in my hand with the shriveled seed. They're called sclerotia, and they can survive for many years. And when they survive and they're near the soil surface and you get wet, they will grow these little mushrooms. These are called apothecia. And they release the ascospores that cause all our problems. So for these mushrooms to grow, it needs to be relatively cool, and you need some saturated soil, and the black structures have to be close to the soil surface, and then they will germinate. Now, once they release the spores, that's kind of the weak spot in the whole cycle. The spores don't actually infect healthy green tissue. It's a rare event if they do. What they need are flower petals. So here you can see a sunflower leaf, and this illustrates the point very well, that there's a flower on it, and that little floret was infected, and the spore landed on it, started to digest it, and from there, it went into the leaf itself. And the same process happens with canola, with dry beans, with soybeans, and it's the same pathogen that does it. So it doesn't need healthy green tissue, it needs those flowers. So if you've ever wondered why we talk about fungicide applications that bloom and not before, it's because there's no flowers around. That's a really critical part of the disease cycle. Okay, and from there, you pretty much know the story. You get the white fuzzy growth, and then you see more black sclerotia develop, and that's how the pathogen survives. So managing it with white mold, or managing white mold with fungicides, excuse me. Timing is important. You need favorable conditions, and you're going to apply in the bloom stages. Now, Michael Bunch at Carrington has been working on optimizing some of these things, and we're going to talk about one component of that here in a little bit. Fungicide efficacy is important, and I would strongly encourage you not to cut rates. There's a rate effect for a lot of the chemicals we work on. A classic example is topsin or T-methyl. 30 ounces is way better than 20. 20 will get overwhelmed in even intermediate disease pressure, and 40 is better than 30. But I would definitely stay at that middle rate or higher. So I mentioned Dr. Bunch. There's also a canola risk map. So if you're familiar with the canola risk map, that's based largely on the pathogen, and it is reasonably effective for predicting the white mold in dry beans and other crops for that matter. Okay, so optimizing the application is where we're going. And I can't show you a ton of data, but I can show you a little bit. So I'm going to go to the North Harvest Bean Grower magazine, and this is the 2021 dry bean research report. So when the North Harvest Bean Growers fund research, a lot of those results show up in this magazine, and there's one research issue a year. And here's the table of contents, and you can see everything from white mold to varieties to herbicide issues. It's a good resource to take a look at. So we're going to go to the article that Michael Bunch has put in on page 18, Improving White Mold Management in Dry Beans. I'm just going to show you a couple things. The first is the first table. I want to give you the idea that he's been doing this for quite a while, and he's pulling a lot of data together. So he's looking at droplet size in this particular group of experiments. He's looking across different market classes, different years, different driving speeds. There's a lot going on here, and it's a lot of really good work. So one of the tables I wanted to put in front of you is the impact of spray droplet size on white mold control in pinto beans. This is table 5. And what I'm going to tell you is that a lot of it is based on canopy closure. And there tends to be that if your canopy is not closed, if it's an open canopy when you're spraying, fine droplets, probably a little bit better. But if that canopy closes, you probably are looking at coarse droplets as a better option. And that's because you need that penetration. So I'll walk you through this a little bit. He's done this work with T-jet nozzles and Wilgers. So we're going to look at just the T-jets as an example. So here's T-jets. Here's canopy closure when the canopy's open. So the canopy's open in that second application. So this whole side is that, whereas this side is canopy at or near closure at the second application. Okay, so each side of these two tables are open and closed canopy. Here you've got the years of the study and what variety was used. And in each case, you have combined analysis, and that's what we're going to focus on. And then you've got beneath this, you've got white mold, that's percent of canopy that's affected. So all the disease data, and then you've got the yield data down below compared to the fine, medium, and coarse droplets. okay? And you got a non-treated control. Okay, so how we would read this, on the left side of the screen, you have an open canopy, you have fungicide applications, open canopy, when you're comparing fine, medium, coarse droplets in a non-treated control. And you can see that all the droplets did a good job at reducing disease severity. 56 is a lot, 42 is a lot too, but it's less than 56. Same thing with a closed canopy, 60 is a lot of disease, and about 40% of the canopy is infected when you actually sprayed. If you look at the yield data here, on the left side, you see the non-treated control at 2,400 pounds. Well, that's statistically different than any of the droplets, fine, medium, or coarse. But you really see a trend where the fine is more effective, has higher yield when the canopy is open. So you can see here it's 3,013 pounds with fine droplets versus 2,800, 2,500 when you have medium or coarse. It's not statistically different, but the trend is pretty solid. On the right side of the screen, you see the opposite effect, where the combined analysis of yield in the non-treated is 2546. When you have fine droplets, it's just under 3,400. Same thing with the medium droplets. When you get into the coarse droplets, it jumps up 150 to 200 pounds. Again, not statistically separated in this particular group, but the trend is consistent. And I would encourage you to take a look at this issue. There's a lot more data that relates to other market classes and a lot of data on both TJets and Wilgers. Optimizing that chemical application is really important. It's a good financial investment to spray lots of times. You want to make the most of it. Switching gears to soybean cyst nematode. Soybean cyst nematode is a parasitic worm and it grows on roots. Now it's soybean cyst nematode because it causes lots of problems on soybeans, but it also infects dry beans. This is a picture I took not that long ago of soybean roots covered with SCN. These are white, cream-colored, little lemon-shaped females full of eggs that are basically parasites on that root. And when it infects dry beans, there's really nothing that screams soybean cyst nematode. This is a picture that Guiping Yang in the Department of Plant Pathology took. You can see some yellowing and some stunting, and that's about it. The only way you'd really know if it's soybean cyst is if you get in and sample or try to find it and look for it. Now this kidney picture was taken outside of the region. This is in an area kind of by St. Cloud, Minnesota, but we know SCN is moving. The North Dakota Soybean Council has been very supportive of a grower-based sampling program, trying to keep an eye on where SCN is. They started in 2013, and since then there's been about 4,700 samples submitted by growers and their advisors. And so how you read this map is all the black circles are negatives, and all the gray boxes are low level positives. And you might want to call them inconclusive because there can be false positives. But certainly some of them are real, maybe most of them, but some of them are also false. But any of the colors, that's real. So green, triangle, and the blue circle are different levels. By the time you get to the yellow square and the red shape, you have high enough levels that you're going to take yield loss in even your best resistant soybeans. Okay, so let's look at this in a different way. So I'm going to take away all the negatives, right? And you can see the eastern, especially the southeast, the eastern part of the state's pretty hot, heavy, but in your region here, you're starting to show all these green triangles popping up all over the place. So we know SCN is moving. We know it's in the region. Most of you probably don't have it yet. That's good, but it's going to continue to spread. So how do you manage this? So the first thing is you want to sample to detect it. It's very difficult to see. Even if you dig the roots carefully, it's hard to know for sure if you've got SCN. So soil sampling in the fall is critical. You can soil sample soybeans or dry beans. I think this is really critical for the dry bean growers that also grow soybeans. You want to first manage SCN in your soybeans if you grow soybeans. So you've got some good tools. You've got genetic resistance. We know how to use crop rotation. There's some seed treatments that can be effective in the right environment. So managing it in your soybeans is important. When you put it back into, when we talk about dry beans again, you want to understand your risk in the dry bean market classes. They're not all equal. We know kidneys are more sensitive than blacks or pintos or navies, for example. And there's a video where Dr. Berlin Nelson and I are talking about SCN. It's called SCN, a big threat to dry bean production. You can Google that or find it on YouTube, and there's the direct link. So let's go back to the North Harvest Bean Grower Research Edition in 2021. we've got some evaluation on SCN resistance in dry beans. And so this article on page 28, I'm going to share with you, and I'm going to share just one table with you. And I'm sorry this is fuzzy. I couldn't defuzz it, but I think you can see it clearly enough to understand that it's different pinto bean varieties and their susceptibility to SCN. And we measure susceptibility to SCN by something called the female index. So like many of the other graphs have showed you, the bigger the bar, the more the disease. In this case, we're measuring how much the female worm can reproduce on the roots of those different varieties. And by the time you get to 100, that female worm likes your dry bean just as much as a susceptible soybean. Now, you can see that the scale here goes from 0 to 45, so that is not the case. So a lot of these are going to be considered resistant, moderately resistant, and I would say La Paz and Maverick probably should be considered moderately susceptible. But there's some pretty significant differences here in the sensitivity and the female index on these. So if you're growing dry beans, just know that the market classes are generally different, and then the varieties within the market classes can be different as well. So if you have some choices and you have SCN, you might want to consider your variety selection. You can get this magazine directly by going to the northharvestbean.org site, and you just need to click on the Grower tab, and Bean Grower Magazine is the first hit, and from there you'll be able to find the research edition from this year and the other years as well. Okay, last thing to mention is root rots. So we're going to steal a little information from soybeans. And the reason we're doing that is we have a small amount of information on root rot pathogens in dry beans compared to the massive amount of information they have on root rots in soybeans. And because there's a lot of different genuses involved, we can learn a few things. So the first is that on this chart, you have Pythium, Phytophthora, Fusarium, Rhizoctonia. Those are all groups of root rot pathogens on soybeans. So let's eliminate Phytophthora for now, because we're not worried about that with dry beans. Then look at this table again. So with soil moisture, we know Pythium loves it flooded. But Fusarium and Rhizoc can occur when it's damp or wet or even dry. With soil temperature, we know some of them like it cool and some of them like it warm. The point is that there's a root rot pathogen for every environment. But maybe the most important thing I want to emphasize is that there's different groups of organisms. So Pythium, Phytophthora, if you grow sunflowers, the downy mildew pathogen, if you grow field peas, Aphanomyces, they're in a group of organisms called oomycetes. And they're essentially algae. Think of them as like algae with little tails that swim around, and you need flooded conditions. You need free moisture for them to do anything. Whereas Fusarium and Rhizoc are fungi. So how they work is one part that's important, but how you manage them with fungicides is also important. So oomycetes and fungi are different enough biologically that if a fungicide works well on one group, it's probably not working so hot on another. And that's hard to show. But we have a little bit of information from soybeans that will help you understand what those seed treatments are doing and what they're working on. So this site, cropprotectionnetwork.com, is a website where groups of extension and research pathologists have gotten together in the Midwest and the Mid-South, created this site, and we create uniform publications. Okay, so this site looks like this, Crop Protection Network. We have topics on corn, soybeans, and small grains. You can click on that and go to the publications, and eventually you can search and you can find a whole bunch of different information. But what we're focusing on for this talk is fungicide efficacy for control of soybean seedling diseases. That's available on the site, but you can Google the title and you'll find it as well. In here, you'll see two tables. These tables are evaluation of efficacy. So how well do the products work, the seed treatments, on these different root rot pathogens, and then a common fungicide trade name. So you can translate how well that scientific name, azoxystrobin, works. You can turn that into what it's actually sold as, let's say Quadris, for example. Okay, so in the efficacy categories, we go from poor to excellent. NR means not recommended, and unknown, there's plenty that are unknown, right? So how you would look at this is you have 6 different pathogen groups, Pythium, Phytophthora, Rhizoc, Fusarium, the sudden death syndrome group, or the pathogen itself, and then Phomopsis. Now we are interested for dry beans probably in Pythium and Rhizoctonia and Fusarium, probably Rhizoc and Fusarium the most. And you have a bunch of different chemicals. So as an example, let's look at mefenoxam. That's rated E, excellent, on Pythium and Phytophthora. Remember, those are the two that are related to algae, the ones with swimming tails and need flooded conditions. But it's not recommended on any of the true fungi. It's very different. Fludioxonil is exactly the opposite. It's not recommended on Pythium or Phytophthora, but it's good or fair or very good on different Fusarium, Bizoc, and different fungal species. Sedaxine is another one I might point out where this is really, really pretty hot on one thing, Rhizoc, right? It's really pretty good on Rhizoc. But again, it's not recommended on Pythium or Phytophthora. And that's because just biologically, those two groups are so different. So once you figure out what you've got in your seed treatment, you can translate that into a named compound. So if you know the active ingredient is metalaxyl or mefenoxam, like we just talked about, you'll see that's either allegiance or apron. So mefenoxam is apron, right? So apron XL has just one ingredient, mefenoxam. So it's probably going to be pretty good for Pythium, Phytophthora, the downy mildew pathogen, whatever. And this will translate beyond the soybeans into dry beans and other crops. Okay, scroll down this table a little bit. Well, there's a group of compounds that mix fludioxonil and mefenoxam. So fludioxonil is the one that I showed you that it's not recommended for the Pythiums, but it is pretty good on Fusarium and Rhizotonia, and mefenoxam is the opposite. So if you've wondered why Apron Max is grouped together, it's because those two chemistries work on different pathogen groups. And the last one that I added in there was sedaxine. So fludioxonil plus mefenoxam plus sedaxine would be something called Cruiser Max Vibrance, or the Vibrance Trio, at least in soybeans. There's names in different crops. But the whole point here is that if you're investing in a seed treatment, it's important to know what you're getting and know what pathogen groups you're managing. And I realize that dry bean growers don't have an infinite amount of choices in seed treatments, but it's important to know what you've got. It's important to know what you can do with them. That is all I have for you today. Thank you for coming to the Roundup, live or recorded. Best wishes.